Every offshore installation like this contains over 10,000 small bore fittings as part of the vital instrumentation control and other systems. Every one of them is under threat from corrosion. Even environmental exposure to salt spray or sour gas can cause vulnerable areas to corrode, and then any extra stresses or strains can mean disaster. Yet many instrumentation tubing users still don't realise that standard small bore fittings are actually opening up a path for corrosion. Corrosion doesn't always strike in the most obvious places. It's the more protected environments like this wellhead control panel which are most vulnerable. On this high pressure unit, salt spray evaporation has formed a concentrated condensate. This collects in the crevice between the nut and tubing and stagnates. The next step is ferrule corrosion and possible failure. Corrosion attacks the weakest link in the chain, the point at which the back ferrule of the fitting grips the tube. The gripping ferrule must be hardened in order to bite through the hard skin of the tubing. The problem is, many commonly used hardening techniques, chrome plating, work hardening or chemical edge treatment, weaken the metal's resistance to corrosion. Chemical edge hardening processes such as nitriding are the worst offenders because they allow carbon molecules to be drawn to the surface of the ferrule, effectively turning the underlying layers into mild steel. The problem's serious, but it's not new. The history of the offshore industry is punctuated by small bore fitting failures. A recent report by the Health and Safety Executive identifies small bore fittings as a major cause of systems failure. Of more than 300 offshore incidents reported in the North Sea every year, over a third are attributed to instrumentation and small bore pipework systems. So, has no one taken notice of this warning from history? Parker engineers recognised this as a major issue and got to the heart of the problem over 15 years ago. Here at its European headquarters, Parker designs and develops instrumentation support solutions which guard against the threat of ferrule corrosion. Parker's specialists saw that corrosion was always going to be a threat to the integrity of ferrules unless they could find a new hardening technique. And in 1986 they found it. Supercase is a unique hardening treatment which penetrates for just a few microns without impairing the corrosion resistance of the stainless steel. This makes it very hard and corrosion resistant on 100% of the surface area with no molecular changes in the core material. The intrinsic spring quality of the steel is retained, so joints can be made and remade up to 80 times or more without opening up an avenue for corrosion. These Supercase treated fittings, for example, show no signs of corrosion after 7 years continuous exposure in an aggressive salt spray environment. By selecting Supercase treated fittings for new projects, either twin ferrule or the unique Parker CPI single ferrule fitting, designers and specifiers can now eliminate a major avenue for corrosion. There's good news for existing installations too. The early signs of corrosion are easy to spot through regular monitoring. Combined with good assembly practice, integrating Supercase within your refurbishment program will eliminate this major threat to the integrity of instrumentation systems. To find out how Parker can help you beat the threat of corrosion, check out www.parker.com/eloop. www.parker.com/eloop.